here we go. We're looking at quadrants. Darn it, that looks terrible. Now, when we're looking at radians, degrees, we're talking about how much we're turning. So we're turning around a circle. And what happens is we have broken up these circles into 4 easier sections to think about. We have quadrant 1, denoted by a Roman numeral 1, quadrant 2, quadrant 3, and quadrant 4. You can also think about like, man, why isn't this clockwise? Why don't we go 1, 2, 3? We don't. Okay, and there's a reason. We'll learn about that a little bit later, but it's going up and over. And the one reason that we can take away right now is because 0 degrees is here. And don't we start going up this way? 0, 90, 0, 90, 180, 270, and then 360. So we are going in this counterclockwise direction. Counterclockwise direction. Go quadrant 1, 2, 3, 4. Now we have characteristics in each of these quadrants. So any angle between 0, oops, wrong side, 0 and 90 degrees, that's in quadrant 1. So we're stuck in this corner here. That is quadrant 1. In quadrant 2, it's any angle between 90 and 180. So we're stuck here. 90 degrees is up here, and we're coming over to 180. That's quadrant 2. Quadrant 3 is 180 to 270, which is right here. Any angle stuck between. And quadrant 4 is 270 to 360. If you forget, some people need a way to remember. So I call them co-quadrants, right? It's like co-CO. So you go in, when you write a C, you go in this direction, okay? This is again for just some people who really need it, right? Just write a C. C for co, if you need it. So what about if I give you 90 degrees? What if I give you 90 degrees? Is this in a quadrant? This is not in a quadrant. Any of the right angles, 90, 180, 270, and 360, these are not in any of the quadrants. Now, there's some other characteristics about these quadrants, is that anything in quadrant 1, the x values are going to be positive, and the y values will also be positive. They'll both be positive. For example, if I pick a point, let's say 1, 1, 1, 1, isn't the x value positive as well as the y value? So not only is the x going to the right, but y is going up. So anything in the upper right-hand corner, x and y's will always be positive. And this is super important to note for later reference. As we use sine and cosine, is going to borrow from these ideas. To be in quadrant 2, our x is going to be negative, but our y is positive. Our x is negative, but our y is positive, going up. So hopefully you guys can see that. Any point stuck in quadrant 2, the x will be positive. X will be negative because we went left of 0, but the y will be positive because we went up from 0. How about what do you think for 3? What do you guys think that's going to be? The x is negative, and so is the y. Because not only do we go left, that's negative, we also go down, that's also negative. Okay, these are, again, just some special characteristics. It's going to be important later as we talk about points on the unit circle. And the last one, let's use yellow. So if I give you negative x and, whoop, not negative x there, because did we go left? No, we actually went right. So x is positive and y is negative. So x is positive and y is negative because x is in the positive direction and y is in a negative direction. Okay, so anything quadrant 4, x is positive and y is negative. So let's give you some examples here. If I ask you, what quadrant is the angle, let's say 79 degrees in? So where would 79 degrees fall? Quadrant 1, 2, 3, or 4? So if it's less than 90 degrees, that means we're stuck in quadrant 1. Quadrant 1. How about 321 degrees? 321 degrees, 300, 180, 270. Oh, we didn't quite make it to 360. We are stuck in quadrant 4. This is quadrant 4. But like we talked about last time, about angles and radians, and this could keep on going over and over again. So what if I wrote, what about angle 400 degrees? 400 degrees, where would that go? We do 360, whoops. We do 360. And isn't 400 just a little bit over 360? So we're stuck in quadrant 1 again. So these quadrants don't go 1, 2, 3, 4, 5, 6, 7, 8. They go back and they repeat. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So this is back to quadrant 1. Because after my first circle, we're back to quadrant 1. Now, this leads us to our next discussion about what we call coterminal angles. Coterminal are angles that stop at the same place, even though they may not be in the same circle. So let me give you a quick example. If I look at the clock at my house, doesn't go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And most people don't have the clocks that go 13, 14, 15. The clocks reset back to 1. So whether I write 1 o'clock today or 1 o'clock tomorrow, the clock will always be in the same spot. And that's what we refer to coterminal angles. Though they might not be in the same circle, same day, they are still in the same position. So let's give ourselves an example of that. If I write 30 degrees, let's call this 30 degrees, counting up, the 0 degrees, going up to 30 degrees. If I walk all the way around the circle, and we come back and we stop at the same spot. Oops. Same spot right here, overlapping, they're overlapping, okay? This would be 360 plus 30 is 390 degrees. Now at 390 degrees and 30 degrees and 390 are coterminal angles. The word coterminal literally means sharing a terminal point or sharing a terminal angle. They stop at the same spot. Now, we can go forward or we can go backwards. If we went in a negative direction, watch, I'm gonna go from 30 degrees, I'm gonna go backwards this way. Going backwards this way. So if you look at me, I went 360 degrees, right? So let's draw it this way. If I go 30 degrees minus 360, because we went in a negative direction, this leads me to an angle of negative 330 degrees. So 30 degrees, comma, 390 degrees, and negative 330 degrees actually are all coterminal. So no matter where we go, as long as we stop at the same angle, it's going to give us what we call coterminal. Now, this is important for us is because we're going to learn something called sine, cosine, and tangent later. And when it comes to sine, cosine, and tangent, this is true. If sine, one second, let me pause this, wait. So 30 degrees, 390, and negative 330. Turns out, if I find the sine of 30 degrees, if I told you this is 1/2, the sine of 390 is also 1/2, as well as the sine of negative 330. That will also be 1/2. All these are going to be related with the same angle. So that's going to be important to us a little bit later. But the idea of coterminal is the idea of angles that stop at the same spot. Well, let's give you guys another easy one. Let's use the angle is going to be 150 degrees. Okay, draw a new circle over here. 150 is over here on the left hand side. 90 plus 60 is 150. So from here, I would like us to find two more coterminal angles, one ahead and one before. So let's do the easy one. Let's go forward. If I go 150 and I go through one full circle over, okay, that's going to be 360 degrees. So 150 plus 360, 510, 510 degrees. So 510 is coterminal with 150. I can go again. Let's go through another circle. 510 plus another 360 gives us 871. Oh, sorry, 870, I'm sorry. 870. So 870 is coterminal with 510 and 150. Let's go backwards. We can say 150 minus 360. What would that be? 210, negative 210 degrees. Now, let's see if that makes any sense. Negative 210 degrees. So, starting from 0, let's start from 0 here. Here's 0. If I go negative 90 and negative 180, is that okay? That's negative 180. And negative 180 with another negative 30, this is negative 180. That gives me negative 210, which brings me right alongside 150 degrees. So our big deal is coterminal angles are related always by 360 degrees because it's just one circle. Sometimes I think of, have you ever seen those parking lots that do this weird shape going up? Right? So if I drop something from here to here to here, these are all, in a sense, coterminal. Right? If I drop something here to here to here, they're not on the same level, but they are the same angle. And that's a big deal about coterminal for us. But honestly, imagine if you're just like spinning around in circles, you're not going anywhere. So if you start off at 0 and you spin around 360, you're still back at 0. You spin around again, you're still facing the same spot, spin around again, and these are what we call coterminal. Just to illustrate this point, okay, so let's take the angle A. See angle A? I can spin this around. Let's say we're at 400 degrees. Now, D is 40 degrees, and we can see both ABC and DCB are coterminal points. If I take A again and I keep going, let's keep going. Ooh. We're back at coterminal points. Keep going. We can go the other way, I think. Let's see if this will work the other way. Oh, negative. Bam. Now, since 40 is an easy number, we can say 40 minus 360 is negative 320. Or if I go forward, oops. 360 plus 40 is 400. Now, this is also included in the link in the homework, so if you guys want to play around with this. Could be a little bit helpful. All right. So coterminal points, how to find those. Next one is we're going to talk about is reference angle. A reference angle is going to be super useful to us coming up, but we have to learn the basic principle of what a reference angle is. So the reference angle is an acute angle. So it's always an angle between 0 and 90. And the second one, it always returns to horizontal. And that's what we're talking about is the x-axis. So let's give a simple illustration. If I draw an angle, let's draw this as 60 degrees. The angle back to horizontal, that would be 60 degrees. That's what we call our reference angle. That looks ugly. That's our reference angle. It's just a vocab word. We're going to use it a lot. But what if I give you an angle way over here? And we'll call this angle here 120 degrees. 120 degrees. Well, what is its reference angle? Remember, first, it's an acute angle. 120 is not an acute angle. It's pretty chubby if you ask me. And the second one, it has to return to horizontal. So what we're going to do is we're going to say, hey, the reference angle here is going to be this guy here. That's my reference angle. Coming back down, whoops. Coming back down to horizontal. And we can say 180 minus 120 is 60 degrees. So my reference angle is 60 degrees here. It's always back to horizontal. That's our goal. Get back to this. You can almost think, how much are you going to fall back to the ground? Let's do one more. Let's do another angle. Let's go from 0 all the way over to, oops. Let's do 240 degrees. Okay, 240 degrees. 240 degrees is not an acute angle. So we're going to return to the horizontal. So in this case, we're going to dig ourselves up. Let's dig ourselves back up. So we know this is 180. So to get back to 180, we know this is going to be 60 degrees. Let's do one off the cuff. The new angle is going to be over here. Oops, let's use a different color. That's going to be 330 degrees. So what's the reference? Remember, coming back over to horizontal. So to get from 330 to 360, we need 30 more degrees. Okay, so that's our reference angle. So to illustrate this point, I'll leave this up for a moment. Our idea here is that what is that angle that brings us back to horizontal? And this can be super important for us because as we use sine and cosine, or as we draw triangles, we don't look at the full angle. We use a full angle to help us find the reference angle. And the reference angle is going to be the most important angle for us. With a calculator, use the full angle. But without a calculator, and we have to do this by hand, we use the reference angle. Okay, let me show you one more thing. Okay, so let's take a look here. If you see this, so the reference angle, I'm going to drag this point around. The reference angle and the angle in quadrant 1 are exactly the same because we're always going back to horizontal. So the angle is 50, the reference angle is 50. But what if I go past to quadrant 2? The real angle is, as we mentioned before, is, whoops, is 120, but the reference angle over here is going to be 60. And that's our definition of reference angle. It's an angle that brings us back down to the horizontal. Let's keep on going. Once we go to quadrant, let's make this angle 150. So 150, my reference angle is 30. It's what's left. Keep on going. If I go to quadrant 3, let's go to 240 degrees like we did before. And our reference angle is going to be 60 degrees, right? That's what's left. And let's do one more. If I pick 330, like we mentioned before, 330 degrees, oops, our reference angle is 30 degrees. Now, this happens if I keep going around the circle. If I pick some huge angle, do you see the reference angle is always whatever gets us back to horizontal. And it's always an acute angle, regardless how big this angle is. Regardless of how big the angle is always back to horizontal. So in this example, 370 is a reference angle of 30. Why? 2 full circles is 360 plus 360 is 720. And after 720, we still went up by 30 degrees. So 360, 720, and we ended up by 30 degrees. Okay. So I think when it comes to finding reference angle, it is helpful to draw it out just a little bit. Even the smallest, most basic graph. If I give you something that says, let's say it's 235 degrees. So what quadrant would 235 be? 235, this is 90, 180, oh, 270, not quite there. So maybe something over here. Doesn't have to be perfect. This is 235. We have to get back to 180, so we can subtract 235 minus 180 is 55. So we know our reference angle is 55 degrees. What if I have something bigger? If it's 302? Well, 302 would take us all the way past 270 into quadrant 4. Doesn't matter how you draw it, 302. But we know to get back, we have to get to 360. So this is 360. What's the difference? 360 minus 302, that is 58 degrees. So we know our reference angle is 58. So I feel like it's easier to draw it if you need to, so you know which way to go. But reference angle always goes back to the floor. Okay.